On this channel, we've often mentioned meteorology but never talked about it. So today we're talking about meteorology without hesitation, repetition, or deviation starting now. Meteorology is the scientific study of the atmosphere with a focus on forecasting weather patterns. In aviation, understanding meteorology is essential as it directly affects flight operations. The atmosphere is a mixture of gases, mainly nitrogen, oxygen, and trace gases, including water vapor surrounding the Earth. Weather occurs in the troposphere, which is the lowest atmospheric layer and extends up to 36,000 feet above the Earth's surface. This is where clouds, storms, and other weather phenomena form. Above the troposphere is the tropopause, marking the boundary where temperatures are very cold with important flight-relevant phenomena like jet streams and clear air turbulence occurring. Other layers of the atmosphere include the stratosphere, mesosphere, thermosphere, and exosphere, with the latter being the transition to space. Although aviation takes place primarily in the troposphere, higher layers influence the weather experienced below. Air pressure is a fundamental concept in both meteorology and aviation. Air is composed of moving molecules that exert pressure on objects. This pressure, measured as air pressure, is what makes flight possible. The curved design of an aircraft's wings creates a difference in air pressure, with higher pressure below the wing and lower pressure above it, generating lift. Air pressure decreases with altitude, and this reduction in density impacts aircraft performance. For instance, as air pressure drops, aircraft engines produce less power and wings generate less lift, requiring pilots to adjust their operations, such as reducing cargo weight. Air pressure also varies with temperature, as warmer air causes molecules to move faster and spread out, thus reducing pressure. This relationship between temperature and pressure is key for predicting aircraft performance on any given day. Pressure altitude is a critical metric for pilots. Aircraft altimeters which measure altitude are calibrated to air pressure. The International Standard Atmosphere (ISA), adopted by ICAO, provides a baseline for calibrating altimeters. The ISA assumes standard conditions such as 1013.25 hectopascals or 29.92 inches of mercury and 15 degrees Celsius at sea level, with pressure and temperature decreasing predictably with altitude. Pilots can use pressure altitude to estimate how their aircraft will perform. If the actual air pressure at an airport is lower than the ISA standard, aircraft performance may be reduced due to less lift in engine power. Temperature also plays a crucial role in aviation. After the sun's energy passes through the atmosphere, heat is absorbed by the Earth's surface, which varies depending on the season, time of day, and latitude. As air temperatures drop, especially when air is lifted by forces like thermals or terrain, the moisture in the air cools, reaching the dew point, which is the temperature at which water vapor condenses to form clouds or fog. This is a common occurrence in aviation weather, impacting visibility and flight conditions. Air masses and wind are also significant factors in meteorology. The Earth's surface influences the overlying air, creating air masses with distinct moisture and temperature characteristics. These are classified as continental or maritime and polar or tropical. Air masses move across the Earth, affecting weather patterns. For instance, a cold polar air mass can bring cooler temperatures to warmer regions until it dissipates. The movement of air from high pressure areas to low pressure areas generates wind, with stronger winds forming when the pressure difference is greater. Wind, which is measured in knots in aviation, is a crucial element for pilots, especially during takeoff and landing. Lifting forces in the atmosphere are responsible for moving air vertically, which can significantly affect weather. Convergent lifting occurs when air moves towards low pressure areas, causing it to rise. Frontal lifting happens when air is forced upward along the boundary of another air mass, while orographic lifting occurs when air is pushed up due to rising terrain like mountains. Finally, convective lifting results from thermals, which is rising warm air caused by surface heat. As air rises, it cools, potentially forming clouds if it reaches its dew point. Aggressive lifting forces, such as fast-moving air masses, can lead to severe weather events like thunderstorms or squall lines, posing significant threats to aviation. In summary, meteorology provides critical insights into how the atmosphere, air pressure, temperature, wind, and lifting forces interact to create weather conditions that affect flight. Pilots must understand these factors to make informed decisions, ensuring safety in the skies.
If you like this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.